Hey guys, Mr. Middleton here. Today we're going to look at some coordinate proofs. At the end of this video, you should be able to complete proofs of quadrilaterals using coordinates. Okay, well, let's start by talking about the tools that we'll need to be able to do. So, name the formula needed to prove the following properties. Opposite sides congruent. Okay, so since we're talking about congruency, we're talking about length, so we need the distance formula. Okay, if we want to prove that opposite sides are parallel, we need to know slope, so we use the slope formula. If we need to know the diagonals are perpendicular, again, perpendicular deals with slope. Okay, and then diagonals bisect each other, then again we're talking about distance. Or actually, that's not distance. If we're talking about diagonals were congruent, we talk about distance, but if they bisect each other, we need to know the midpoint. Okay. Revisiting these, remember that parallel lines, slope, for parallel they're the same slope, and for perpendicular lines they have opposite reciprocal slopes. Okay. Alright, so let's look at this first proof. Okay, they want us to prove that the following is a parallelogram. So we need to know what's the definition of a parallelogram. Remember, we have two pairs of parallel sides. Okay, and so if we're going to try to show that this is a parallelogram, we're going to show that the sides are parallel. So what formula will we need? We'll need slope. Okay, remember that's y2 minus y1 over x2 minus x1. Excuse me, that should be in your last notes. So if I want to show that this is a parallelogram, I'm going to need to show that CD is parallel to AB. CD is parallel to AB. And I'm also going to need to show that CB is parallel to DA, or AD, I'll just say that. Okay, and so let's find slope. So CD, what's the slope of CD? Well, y2, 2b, minus 0 over 0 minus 2 minus negative 2a. So I'll say plus 2a. Should label this is for CD. So that gives me 2b over 2a, which is b over a. So the slope of CD, excuse me, is b over a. I'll do the same thing for AB. So the slope of AB will be AB 0 minus negative 2a, or sorry, minus negative 2b, so plus 2b. 2a minus 0, and so again 2b over 2a, which simplifies to give me b over a. So CD is parallel to AB. They both have a slope of b over a. Make sure everybody knows this is b. Okay, and now I'll have to do the same thing for the other side. So CB, I can do the same thing, negative 2b minus 0 over 0 minus negative 2a, or plus 2a. And so when I do that, this is for CB, I get negative 2b over 2a. I can simplify that, and that gives me the slope of negative b over a. And then I'll do the same thing with AD, and I'll get 0 minus 2b over 2a minus 0, and negative 2b over 2a. Simplify that, I get negative b over a. So now, again, I can see that CB is parallel to AD because they both have the same slope of negative b over a. So, since both pairs of opposite sides are parallel, then the figure is a parallelogram. Okay? And it's important to summarize what you've shown, which is why I did this last sentence. Okay? So, this last sentence, important to show, hey, this is what the work should be telling you. All right. Flip it to the back side. Okay. We want to prove that the diagonals of this parallelogram bisect each other. Okay, bisect means cuts in half. Okay, so how will we do this? Well, we'll want to see what the midpoints are. Okay, we'll find the midpoints of both diagonals. Now, if they cut each other in half, then they should have the same midpoint, because that means they both intersect the same place. That's the halfway point for both of them. So I'm going to find the midpoint of MT, and I'm also going to find the midpoint of ER. Midpoint of ER. Okay, remember the midpoint is finding the average of the x coordinates and the average of the y coordinates. So the average of the x coordinates for MT will be a plus a over 2. The y coordinates would be 2b plus 0 over 2. So that's 2a over 2, comma 2b over 2, or a comma b. So the midpoint of MT, let's write this here, is AB. I'll do the same thing for ER. Okay, average of the a coordinate or the x coordinates 2a plus 0 over 2. Average of the y coordinates 2b plus 0 over 2. And so that gives me 2a over 2 and 2b over 2. Simplify that, and that gives me a comma b. And so the midpoint of ER is a or b. So my summarizing sentence, since both diagonals have the same midpoint, the diagonals bisect each other. Abbreviate midpoint. Bisect each other. Okay. Alright. Okay, final one, and I will tell you that I will leave this to you to complete, but I'll help you start it off. Okay, it says prove that the diagonals of this rectangle are congruent. How will we show this? Okay, when we talk about congruency, we're talking about a length, and that means we're going to be using the distance formula. Remember that the distance formula, distance equals square root of x2 minus x1 squared plus y2 minus y1 squared. Okay, and so we want to show that the diagonals are congruent, so I need to make sure that I'm organized enough to know what my diagonals are. We've got DB as one of the diagonals and AC as the other. Now remember that we don't necessarily need to come to a really nice number, we just need to see that it's the same thing on both sides. So for DB, my distance will be the difference of the x's. So for one I have 0, other I have k, so I'll say k minus 0 squared, plus the difference of the y's, and that's 0 minus m squared. Okay, and then you can go through and do this. So notice here, k minus 0 gives me k squared. Okay, this is negative m squared, but anytime I'm squaring a negative number inside parentheses, it just becomes positive anyway. And that's why we square it, because it doesn't matter what direction we do. So we found the distance of DB to be the square root of k squared plus m squared. Find the distance of AC. Okay, and then give me a summarizing sentence that shows me what you found. Alright? So hopefully at the end of this video, you are able now to identify which formula you'll need to use and identify how you can prove things of a quadrilateral in the coordinate plane. See ya.